Hi everyone, welcome to another video. Now, we are looking once again at hyperbolas in this video, and we are going to put this together with a technique that we've been doing this entire topic, which is solving simultaneous equations. The only difference now is we're solving these equations when hyperbolas are involved. So what we're going to do, we're going to solve these algebraically, then also just confirm what we found by drawing the graphs as well, because we now know how to do that. So these two questions we're going to do require us to find the coordinates of the points where y equals 1 over x, this hyperbola, when this intersects with the point y equals to 3. Now we have two simultaneous equations here. One is y equals to 1 over x. This is my equation 1. And y equals 3. That's my equation 2. So remember, with simultaneous equations, the point where these two intersect, the y values are exactly the same. And the x values are also exactly the same. Now, we're going to solve this by substitution because we know that y is the same as this y, but then y also equals to 3. So we're going to substitute this 3 in place of the y over here. So what we're going to do, we're going to sub y equals 3 into equation 1. So in place of this y, I'm going to put 3, and then I have 1 over x here. Now I want to solve this. So I need to get the x on its own here. But it's a little bit tricky because the x is on the denominator here. So I need to somehow think about getting it onto the other side so that I can start to isolate the x, because it's no help to us here on the denominator. So what I'm going to do is I'm going to multiply both sides by x. That's going to undo the division of x over here. So I get 3x on the left, and then here I just get left with 1. And now x is multiplying by 3 here. So I want to divide both sides by 3 to cancel out this 3 and get me x on its own. So I'm left with x equals to 1 over 3. So I've found the particular point, the x coordinate where these intersect, and I can find the y coordinate also by just substituting this back into one of these equations. Now we looked before that since this is intersecting, we talked about this I should say in a previous video, since this is intersecting with a line, the y coordinate is always going to be 3 here. So we can think of this as substituting it into equation 2, which just gives us y equals 3. But substituting x equals a third into here as well will give us the same thing. This is like saying 1 divided by a third, which gives me 3 as well. Let's actually just check that because some people may be skeptical, but let's substitute x equals 1 into 3 into equation 1, and that's going to give us that y equals 1 over a third, or in other words 1 divided by a third, because that's what a fraction tells us. And remember, when we divide a number by a fraction, that's the same as multiplying by its reciprocal. I've talked about this at length before. Now, this gives us 1 times 3 over 1, or 1 times 3, which just gives me 3. So we can say, therefore, the point of intersection is the x coordinate was 1 over 3 and the y coordinate was 3. Now, because we know how to sketch our hyperbolas now, let's just confirm this by drawing this out. So I have y, I have x. Now I'm looking at my hyperbola of 1 over x, which looks kind of like this. And I have a line of y equals to 3, which is up here. This is y equals 3. This is y equals 1 over x. Now, remember, with these particular things here, these hyperbolas, here we have the point 1 to 1. Now, when x equals to 1/2, when x equals to 1/2, y equals to 2. This is just from our table of values. So if I go this way, for example, if x is 2, my y is going to be 1/2, and I'm always going to get this reciprocal relationship. Now, if I did as well 1/3, substituted in x equals 1/3, x equals to 1/3, my y is going to be 3. And this is the intersection point between the two, where my hyperbola meets my line. And I can also see that from when I substituted in x equals 1/3 into my hyperbola equation, y equals 1 over x, I also got 3 in the y as well. Now this is just a way we can visually show this. We can also always do this algebraically, which sometimes does end up being a little bit easier, like we did up here. Now, we're going to do one more example to wrap up this video. We want to find the point of intersection between that same hyperbola, y equals 1 over x, and this equation of a line, y equals to 4x. So, my equation 1 is y equals 1 over x, and my other one is y equals to 4x, which is equation 2. And once again, I'm going to substitute, because I'm finding a point of intersection, so these y's are going to be exactly the same. So I can substitute in 4x in place of this y over here. So I'm going to sub y equals 4x into y equals to, let's just write equation 1. Okay, so that gives me 4x equals to 1 over x. So I have x's on both sides here. I want to kind of group these together because these are like terms. So I'm going to do a very similar thing. I'm going to multiply both sides by the x here. That's going to cancel out this one over here and get all the x's together on the left hand side. So that's going to give me 4 times x times x. I can simplify that by writing 4x squared, and that equals to 1. Okay, so that's good. Now we just want to get the x on its own. So we want to isolate just the x. So we're going to divide both sides by 4. That's going to cancel out this one here, leaving me with x squared on the left hand side, equaling to 1/4 on the right hand side. And I want to undo the squaring here because I don't want x squared, I just want x. So I'm going to take the square root of both sides. That gives me x on its own here. And on the right hand side, I can have a positive or negative answer. Because remember, timesing 2 positives gives me a positive, but timesing 2 negatives by each other also gives me a positive. So I can get 2 solutions here. X is equal to plus or minus 1/4. Or, in other words, I can take the square root of 1 and the square root of 4, which gives me plus or minus 1/2. And we can just check that this is true. If we take the positive case, half times a half gives me 1/4. The negative as well, negative half times negative half, that gives me a quarter as well, because the two negatives cancel out to give me a positive. Okay, sweet. So these are my x coordinates, and I want to substitute these back in to one of my two simultaneous equations in order to find the y coordinate. Now I'm going to substitute it back into equation 2 because it's going to be less fiddly because we don't have fractions. So once I have my x value, I'm going to sub x equals to plus or minus 1/2 into equation 2. So one of those is going to be y equals to 4 times 1/2, positive 1/2, and y equals to 4 times negative 1/2. So I'm substituting both the positive and negative half into equation 2, y equals to 4 times x. Okay, so this gives me 2 here. So half of 4 is 2, and negative 1/2 times 4 is going to give me negative 2 here. So I have 2 points of intersection. Therefore, my points of intersection are, one of those is 1/2, positive 1/2, and 2. And my other one is negative 1/2, negative 2. And there we go. We're doing it like we've solved all of our other previous simultaneous equations. Whether they're linear or non-linear, we can do them by substitution in the same way. Now let's just clarify that this is right graphically. So we're going to draw my two axes. So I have this one here, and this one here, and I have a line y equals to 4 over x. So let's actually just sketch in a couple of points here. So this is 1, 1, negative 1, negative 1. And my y equals to 4x is a straight line with a gradient of 4. So it looks something like this. This is my y equals to 4x. That's intersecting with my hyperbola y equals 1 over x. And we can kind of see that the points we came up with roughly check out. Because here, this looks like my point of negative 1/2, negative 2. This is my negative 1/2, negative 2. And I have this one up here as well, which looks like the x coordinate is 1/2 and the y coordinate is 2. So once we do this algebraically and just solving the simultaneous equations by substitution, we can just clarify that this actually works by just doing a rough sketch, and we can kind of see that it ends up working out in the way that we predicted by solving the simultaneous equation. But that brings us to the end of hyperbolas. Thank you so much for watching this video, and I'll see you next time.